This video we're going to go more in detail about circles. So chapter 12 is a lot about circles, their tangent lines, chords, perpendicular lines in them. So first let's just talk about arcs. So minor arcs, remember, are smaller than a semicircle, and we always label them with 2 letters. So I automatically can eliminate these two because they don't have 2 letters. If I look at AB, that's a semicircle. DB is half smaller than a semicircle, so that's going to be my minor arc. My major arc should be bigger than a semicircle and should be with 2 letters, so we're going to eliminate those ones. So if I look at ADB, okay, that's going to be my semicircle because it's half of a circle. If I do DBA, that's going to be my major arc. Okay, which is a semicircle in L, so I can eliminate the one that has 2 letters. So if I start with ADB, I go ADB, and that's half of my circle, so that's going to be my semicircle. What is the degree measure of TUR? So remember, anytime you have an arc measure, its central angle or the angle across from it should be the same, so that's also going to be 32. And then we also have a bunch of straight lines. So this is going to be 180. To find this angle here, I do 180 minus 32 to get it. So that angle is going to be 148. And then we are trying to find TUR. So I'm going to add 90 plus 148 and get 238 is my answer. Okay, so now we're going to start chapter 12, tangent lines and chords of circles. So first off, what a tangent line is. A tangent line touches the circle once, and then it's going to make that perpendicular line. So you can see that it's touching your circle right here only once. It just grazes it, and then it makes that straight line. Okay, it's also going to come with a diameter or radius a lot of times to make that perpendicular line. So the next one is the theorem, if you have a line that's tangent, then it will make that perpendicular line with the radius. So right here we got those 2 right angles. So if you have a tangent line that touches your circle, the radius or diameter will then be perpendicular to it and vice versa. Okay, if I have 2 tangents, so I have this tangent line and this tangent line, they're going to be congruent to each other. So I have AB being congruent to BC. Okay. What is the measure of G? So anytime I have a tangent line which touches once, like this, it grazes it, it's going to create a right angle. So in that we have a triangle. So if I did 68 plus 90, I got 158. And if I subtract that from 180 degrees, because that's how many degrees I have in a triangle, I should get my last angle, which is 22. Now here's the hardest part. So I'm going to erase this. We're going to try to find the radius, that R, okay? Anytime you have the radius, any other spot that you have the radius, it also represents R. And it's a right triangle, so I'm going to use Pythagorean theorem to find it. So across from my right angle is going to be my C, so on the other ones I have 12 squared and R squared. Problem is, let's say this represented 3. To do that entire C value, you would normally do 9 plus 3, okay? But it's not 3, it's R. So in this situation, we're going to do R plus 9 to get that entire C value, and then we're going to square it. 12 squared is 144. This squared means I write it out twice. That means there's 2 of them. And then we're going to have to either FOIL, distribute, or box it up. Okay, I'm going to FOIL. So F stands for first, so I'm going to do my first 2 terms and multiply them and get R squared. O stands for outer in FOIL, so I have 9 times R, which is 9R. I is inner. And L stands for my last term, so 81. And then you always multiply them. Now we're going to go ahead and solve for R, so I can go ahead and combine these like terms to get 18R. Let's go ahead and get our numbers on one side, so I'm going to subtract 81. And I'm running out of space, so 144 minus 81 gets me 63. Let's go ahead and get our R squareds on the same side. R squared minus R squared, they're going to cancel. So I have 63 equals 18R, so we're going to divide by 18. And my radius is going to be 3.5. So it represents the radius of both of those. Okay, find the values of the variables. Okay, so in this situation, I have two tangent lines. So that means their radiuses create right angles. Oop, that's a bad right angle. There. Okay. If I have a four-sided figure, that's going to be a quadrilateral. It's a weirdly shaped quadrilateral, but that means all of the angles will add to be 360. If you don't remember, n minus 1 times 180 gets you that 360. So if I add all of my angles, because those right angles are 90, it should equal 360 degrees. So 35 plus 90, I have 215 plus my missing angle. We're going to subtract by 215. Oops. So 360 minus 215. So that angle is 145 degrees, or you can see that these are both supplementary. Okay, so that means 180 minus 35 should get me whatever this angle is here. This one, if I have a radius here, that means this one's going to be x again. This is my tangent line that's just grazing my circle, so that's where my right angle occurs. So this time I have x squared, I'm going to write it higher, x squared plus 3 squared equals my c squared, so x plus 1 squared, because you're including that entire c. So x squared plus 9 equals, we write it out twice so that we can FOIL. So F stands for first, so x times x is x squared, O is outside, I is inside, L is last. And remember, you're multiplying. Let's go ahead and combine our like terms to get 2x, and then we're going to solve for x. So let's go ahead and move that x squared over. Well, x squared minus x squared cancels on both sides. So we're going to subtract 1, divide by 2, so x equals 4 this time. So that would be my radius for both of those x's. Okay, M is inscribed. Inscribed means it's inside, it's written in the inside of the quadrilateral A, B, C, D. So that quadrilateral on the outside. What is the perimeter? Perimeter means we add up all the sides. I said my tangents are going to be congruent. So here's a tangent and here's a tangent. So that means this is also going to be 9 inches. This is a tangent. This is a tangent. So this one's going to be 5. This one's going to match with the 3, and this one's going to match with the 2. So perimeter, we need to add it all up. So 9 plus 9 plus 5 plus 5 plus 3 plus 3 plus 2 plus 2. So 9 plus 9 plus 5 plus 5 plus 3 plus 3 plus 2 plus 2. We get 38, and perimeter we're just adding, so we're going to leave it in inches. Determine whether the tangent line is shown in the diagram. So remember, here's my tangent line. It's grazing my circle, so that should be my right angle. So basically, we need to see if it actually is a right triangle, because if it's not a right triangle, that means it doesn't create a right angle, which means it's not tangent. So to do that, we need to use Pythagorean theorem. So 4.5 squared plus 10 squared equals my C, or what sits across my right angle, so 12 squared. It should equal it if it's a right triangle. So this gets me 20.25, 100, 144. 120.25 does not equal 144. So this is not a right triangle, which means that that line's not going to be tangent. Okay, so use a word from the list to describe each picture. So this one we can automatically assume is my radius because it goes from the center to the outside. All the way across and then through the center is going to be my diameter. A piece of the outside is going to be the arc. Diameter, radius. Anyone that has an actual angle in it, we have the central angle here, if I can write it, because it goes through that center. Bisect means it's cutting something in half, so this one's going to be the bisect. And the only one I have left is chord. So chord is one that doesn't go through the center, but it goes from one side of the outside of the circle to the other side. So it just doesn't go through the center this time. So we're going to be talking more about chords in a minute here. Okay, so congruent central angles have congruent arcs. So these arcs will be congruent, which have congruent chords. So anytime that there's a chord in it, it will also be congruent. This is a good one here. Make sure you're writing this one down. So chords are equidistant from the center are congruent. So if they are equally distant from here to here, then they will be congruent and then also perpendicular. In a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord in its arc. Okay, so here's my chord. If it is perpendicular to that chord, then it means it's bisecting that chord or cutting it in half. Or vice versa, if it is bisecting that chord, it will also be perpendicular. So it works both ways. Okay, so we're just going to label some central angles that are congruent and some chords that are. So if I have QGR, it's also congruent to angle SGT and the central angles on this one. So angle JBK and angle MBL. Remember, the one in the center is the one that we really care about. We also have chords in it that are congruent. So if I have QR, it should be congruent to ST, which is also congruent to the chords JK and ML. As long as they're equidistant from the center, they should be congruent. Okay, so if they are equidistant, that means these should be congruent. So this one should be 3.2 as well. These ones are equidistant. So if this part of it is 12, that means the whole thing, since they're congruent, that means that whole thing is 24, which means X. If they are if they're equidistant, that means the chord should be congruent. So this is 24, which also means this arc will be the exact same, that 120. My last one here, we're going to have to use Pythagorean theorem. You can see that there's a right triangle. A lot of these, when you have chords and right angles, you can make right triangles. So the whole thing is 20. That means this little guy is going to be 10. So I'm going to do x squared plus 10 squared equals 14 squared. X squared plus 100 equals 196. Subtract 100. X squared equals 96. Opposite of squaring is square rooting, so x is going to equal 9.8. Okay, here are my last two examples. Sorry that they're poorly drawn. So if I look at the first one here, that whole thing is 10, which means part of it is going to be 5. This is also 6.3 here. So x means if that whole thing is 10 and part of it's 5, that means that's going to just be 5 because I'm only wanting half of it. Okay, this one's hard. So we need to somehow get this radius, that x. So I could draw a radius technically anywhere on this circle and be good, but I need to somehow relate it to those two given lengths. So if I go like this, I now have a right triangle. So if that whole thing is 9, that means this is going to be 4.5. And now you can use Pythagorean theorem to find that actual radius, which then is also x. So I'm going to do 4.5 squared plus 1.9 squared equals my c squared. So 4.5 squared is 20.25. 1.9 squared is 3.61. We add them to get 23.86. Opposite of squaring is square rooting. So that c, or that radius, is going to be 4.9.